Hello students, welcome back to physics class. In today's class, let us discuss an important topic in physics, that is Newton's second law of motion. So Newton's second law of motion can be understood in two ways, two methods. Okay. So two different methods we'll be discussing today. So going for the first method, Newton's second law of motion gives the quantitative measurement of force. Only the quantitative, how much quantitative measurement of force. So this Newton's second law of motion actually based on the concept that whenever force is applied on the body, acceleration is produced in the body. So whenever we apply some force on a body, the body is set into acceleration. So Newton's second law is based on this concept that whenever force is applied on a body, acceleration is produced in the body. So based on the method 1, it was explained, the Newton's second law is said like this. Okay, so case 1, method 1, if you consider Newton's second law of motion. Newton's second law of motion. Okay, so what we observe that whenever we consider a body having a mass m and we have applied a force F, then this body is set into acceleration, and this acceleration produced is always directly proportional to the force applied on the body. That means less amount of force is applied, less amount of acceleration is produced on the body. Large amount of force is applied, large amount of acceleration is produced inside the body. That means the acceleration produced in the body is directly proportional to the force applied on the body. It was also observed that the acceleration produced in the body is inversely proportional to the mass of the body. That means heavier the body, lesser will be acceleration for the same amount of force, and very light the body, for the same amount of force the body will move with larger acceleration. That means heavier mass will move with less acceleration and lighter mass will move with larger acceleration for the same application of force. Hence we can conclude that the acceleration produced inside a body is directly proportional to the force applied on the body and inversely proportional to the mass of the body. So combining these two, we can conclude that acceleration of the body is proportional to force applied on the body and are inversely proportional to mass of the body. So bringing this mass the other side, then ma is proportional to F, or in simple form F is proportional to ma. F is proportional to ma. Hence Newton's second law can be said as this. The force acting on a body, the resultant force acting on a body is directly proportional to the product of the mass of the body and acceleration of the body. The product of mass of the body and acceleration of the body is directly proportional to the resultant force applied on the body. This can also be written as F is equals to, proportionality is removed, means equals to some constant K into ma. F is equals to K into ma. So children, suppose if we consider if the value of F is taken as 1 unit of force, and for m if you consider 1 unit of mass, and for a if you consider 1 unit of acceleration, any unit whether CGS, MKS, SA, whatever you consider, 1 unit of acceleration, then this is 1, this is 1, this is also 1. then 1 is equals to k into mass is 1 and acceleration is 1. 1 is equals to k into 1 is k. Hence we can conclude that the value of k is equals to 1. Then this implies the value of k is equals to 1. I hope you understood, children. So as we know the formula F is equals to k into ma, then if F is considered as 1 unit, M is considered as 1 unit and A is considered as 1 unit, clearly K must be 1. After substituting in the above formula, we have F can be written as, instead of K, I considered it as 1. So 1 into MA, that is nothing but F is equals to MA. So based on this, based on this formula or based on this method, we can state the Newton's second law as the net force or the resultant force acting on a body is directly proportional to the product of the mass of the body and acceleration of the body. And remember that the force acting on the body is always in the direction of the acceleration produced inside the body. That means the direction of acceleration and the direction of force always in the same direction. Okay, so this is all, this Newton's second law is explained in this method. The Newton's second law is also explained in second method, that is based on the law of conservation of momentum. Not exactly the linear momentum, simply change in momentum, the rate of change of momentum. So method 2, if you consider, so Newton's second law of motion in method 2, the rate of change of momentum, what they are saying is, method 1, I'll write to the definition. So this method 1, if you consider, let me write down the definition statement. Newton's second law of second law of motion in the first one. The magnitude of resultant force acting on the body. What is that, children? The magnitude of resultant force acting on a body is, magnitude of resultant force acting on a body is directly proportional to what is this? This is mass and this is acceleration, product of the two. Proportional to product of mass of the body and acceleration of the body. Mass of the body and acceleration produced in the body. So this is the first statement. The magnitude of resultant force acting on a body is directly proportional to the product of mass of the body and acceleration of the body. And remember that the direction of force, applied force, and the acceleration will be in the same direction. Okay. Now based on the method 2, Newton's second law can also be said like this. The rate of change of momentum, the rate of change of momentum of a body directly proportional to the rate of change of momentum of a body is directly proportional to the net external force applied on it or resultant external force applied on the body. the rate of change of momentum if the body is directly proportional to the net external force applied on the body. That means first of all, in order to understand this in a clear way, let us try to consider a body of mass m initially moving with velocity u. Okay, let us consider a body of mass m moving initially with velocity u. So whenever some force is applied on the body, so whenever some force F is applied on this body, what happens means its velocity be changed to some v. Okay, whenever because of the application of force, the velocity of the body is changed to v because of the application. Initial velocity was u and final velocity was v. So what is the initial momentum, children? The initial momentum is nothing but mass into initial velocity, that is mu. And what is the final momentum, children? Mass into final velocity, that is mv. Then what is the rate of change of what is the change in momentum, children? Change in momentum is nothing but P final momentum minus initial momentum, that is nothing but mv minus mu. So if I would like to find out the rate of change of momentum, because I want the rate of change of momentum, rate of change of momentum is nothing but change of momentum means this mv minus mu, that is change in momentum. Rate of means this rate meaning time, okay, divided by time. So rate of means by time. Okay, so rate of change of momentum, let us suppose that initially at t equals to 0, this might be the value, momentum is mu. At after some time t, this momentum be some mv. Okay, then this will be mv minus mu by t minus 0. Hence the rate of change of momentum can be given as, what is this, children? Let us take m as common, then you will be getting as v minus u by t. So what is this equals to? The rate of change of momentum of a body is directly proportional to, that means this m into v minus u by t is directly proportional to, what is that? Net external force applied or the resultant force applied. What is that, children? The rate of change of momentum is directly proportional to the net external force applied, that is F proportional to m into v minus u by t, or F again can be written as m into v minus u by t. So this can, or it can also be written as F proportional to m into v minus u by t. Children, what do you mean by v minus u by t? Change in velocity by time taken. Change in velocity, the rate of change of velocity is nothing but acceleration. Hence we can write F is proportional to, this is m, v minus u by t is nothing but acceleration a. Hence F is proportional to ma, or F is equals to k ma. For k equals to 1, F is equals to ma. The same concept. Okay, so the two statements what I have discussed regarding the Newton's second law of motion was, first of all, the magnitude of resultant force acting on a body is directly proportional to the product of the mass and acceleration of the body. Case 2, what we have discussed is the rate of change of momentum of a body is directly proportional to the net external force applied on the body. So two methods we can define the same statement. I hope you are getting it, children. So based on that, let us try to understand the units of this momentum. Okay, children. So to understand the units of this momentum, and one more thing, children, I want to tell you is the Newton's first law can also be explained based on the Newton's second law. To make you clear, so let us have a look to understand Newton's first law. Children, let us consider that the body initially moving with what velocity? U. Here also if you consider the body moving with the same velocity, that means if you consider a body initial velocity u and the final velocity of the body is also u. Same velocity. If a body moves with the same constant velocity before and after, then what is the value of f can be written as f is proportional to m into v minus u is nothing but final velocity also u, initial velocity also u. U minus u how much, children? 0. 0 by t is 0. 0 into anything is 0. So force acting will be 0. That means whenever a body moves with constant velocity, then the net force acting on it is 0. That means in the latter case, if no external force acts on the body, f is 0 means no external force acts on the body, then the moving body, the body moves with same constant velocity. What was our statement? Two ways I have told you that. So every body continues to be in its state of rest or uniform motion unless it is acted by an external force. That means if no external force is acting on it, the body moves with constant velocity. No external force acts on it, the body moves with constant force. Similarly, let me also conclude with the second case. Suppose that the body's initial velocity is 0. The initial velocity of the body be some 0. Then definitely if body is moving with constant velocity, as I said, then final velocity of the body will also be 0. Then 0 minus 0 is 0. 0 upon t is 0. 0 into mass is 0. So in that case also we have f is equals to 0. So initial velocity 0, what does it mean? The body is at rest condition. So final also the body is at rest condition. That means when no external force acts on a body, the rest body will be in rest itself and the moving body will be in constant motion. So the latter statement can be, every body continues to be in its state of rest or uniform motion when no external force acts on the body. So no external force is not acting, the moving body will move with the same constant velocity and the rest body will move at the rest condition only. So we can explain the Newton's first law with the based on the Newton's second law. This is the mathematical form and that is the general format. Okay children. Now let us continue our concept with the SI units of this force. Okay children. So now the next topic, if we consider this, is all about the absolute unit of forces. Okay, units of force, whether through whether you go with the first case, that is F is equals to proportional to MA or F is equals to MA in the first method, or here also F equals to MA means F is equals to K MA for F equals to 1, M equals to 1 and A equals to 1, K is equals to 1, then F is equals to MA. So both means the same. Second method also F equals to MA, mathematical form. First method also F is equals to MA. So based on that, let us try to define the units of force. Moving to the SI units of force. So we know the formula for force is MA. Okay. So what is the units of force, children? Formula force is F is equals to MA. So SI unit of force is F is equals to mass in SI units measured in kg, acceleration is measured in meter per second square. So force is equals to kg meter per second square, as this concept is explained by Newton. As a token of respect, we have also given force is also measured in Newton. So force is either equals to kg meter per second. SI unit of force is either represented as kg meter per second or newtons, where 1 Newton is equals to 1 kg meter per second square. Remember this, children. 1 Newton is equals to 1 kg meter per second square is the SI unit of force. Similarly, if you would like to understand the CGS units of force, then F, force in mass in CGS system is written as, instead of kg we'll go for gram. Acceleration instead of meter per second square we represent it centimeter per second square. So instead of either you can write kg meter per second square or Newton. Similarly you can also represent the CGS system of forces gram centimeter per second square or dyne. Okay children, that was Newton, this is dyne. That was kg meter per second square and this is gram centimeter per second. So let us try to understand the relation between Newton and dyne. Important children, relation between Newton, let me write it as full form, Newton and dyne. So how many dynes make a Newton? Children, we know that 1 Newton can be written as 1 kg meter per second square, isn't it? 1 Newton we can write it as 1 kg meter per second square. This is nothing but 1, instead of kg I would like to convert in grams. 1 kg is how many grams? 1000 grams. So this can be written as, instead of 1 kg I wrote it as 1000 grams. Kg 1000 grams. Meter, 1 meter how many centimeters? 100 centimeters. So this will be 100 centimeters. Second square, SI system also second square, CGS system also second square. So no need to convert the second square as it is. So this is how much children? 1 into 1000 is 1000, 1000 into 100 is how much children? 1 lakh. So it's nothing but, let me represent the same in zeros. 1, 2, 3 and these are 2, totally 5 zeros. Units are gram centimeter per second square. Gram centimeter per second square. So how many zeros? 10 power 1, 2, 3, 4, 5. 10 power 5 gram centimeter per second square. So 1 Newton is equals to 10 power 5 gram per centimeter per second square. Children, but what is this value? You already know that the value of, 1 second. Yes, here force is nothing but 1 gram per centimeter square or 1 dyne. So clearly we have, what is the relation between this? 1 dyne is equals to 1 gram centimeter per second square, where 1 dyne is 1 gram centimeter per second square. So here how many gram centimeter per second square is a 10 power 5 gram centimeter per second square. Hence we can say that 1 Newton equals to 10 power 5 gram centimeter per second square can be written as dyne. So remember this children, the value of 1 Newton is equals to 10 power 5 dyne. Okay children, so 1 Newton is equals to 10 power 5 dyne. You need to remember this at any cost. Now one more units I would like to introduce to children, that is gravitational unit of force. What was that? Gravitational unit of force. This is one more unit of force children. Yes. So gravitational unit of force is somehow written like this children. kg weight. Gravitational unit of force is something like kg weight, or another form it can be also written as kg force, SI unit. SI unit of gravitational force is either written as kg weight or kg force, where 1 kg weight is nothing but 1 kg, okay, into, instead of weight I can write the value of acceleration. No, here F is equals to ma. here F is equals to ma, but on the surface of the earth the value of a is taken as F is equals to, on surface of the earth acceleration is nothing but acceleration due to gravity, that is mg. So mass as it is 1 kg, but weight means that gravity, due to gravity whatever is there, the value of acceleration due to gravity on surface of the earth is 9.8 meter per second square. How much is that? 9.8 meter per second square. Hence the value of 1 kg weight or 1 kg force is nothing but 1 into 9.8 is 9.8 kg meter per second square, or simply 9.8, instead of kg meter per second square I can also represent with Newton. So this you need to remember. The value of 1 kg weight or 1 kg force equals to 9.8 kg meter per second square or 9.8 Newton. So this is all about in SI system. If you would like to represent the same in CGS units of gravitational force, then instead of kg you will be having gram weight. What is that? Gram weight or gram force, where the value of 1 gram weight or 1 gram force is equals to 1 gram mass as it is, F is equals to mg. Force means 1 gram weight, mass means 1 gram. Gravity, acceleration due to gravity in CGS system, here 1 meter per second square can be written as how much, children? Okay, so 100 centimeter per second square. So 9.8 meter per second square equals to 9.8 into 100, that is nothing but 980 centimeter per second square. So how much is that? The value of 1 gram weight equals to 1 gram into 980 centimeter per second square. Hence 1 gram weight is equals to 1 into 980 is 980 gram centimeter per second square, or simply 980 gram centimeter per second square can also be written as dyne. So dyne. Okay. So these things you need to remember, children. Okay. So 1 kg weight is 9.8 kg meter per second square or 9.8 Newton. 1 gram weight is 980 gram centimeter per second square or 980 dynes. 1 Newton is 10 power 5 dynes. Okay. 1 Newton means 1 kg meter per second square. 1 dyne means 1 gram per centimeter square. Okay, children. So let us recap whatever we have discussed till far. So Newton's second law of motion can be explained by two methods. Method 1, the magnitude of force acting on a body is directly proportional to the product of the mass and acceleration produced inside the body, and the direction of acceleration and force are always in the same direction. Based on the method 2, what we try to explain is the rate of change of momentum of a body is directly proportional to the product, directly proportional to the net external force acting on the body. The rate of change of momentum of a body is directly proportional to the net external force acting on the body. Based on that, we can also explain the Newton's first law. What is Newton's first law state? If no external force acting on the body, the body at rest continues to be in its state of rest, and the body in motion continues to be in the state of uniform motion. And case 3, what we have explained is all regarding the units of force. Units of force based on the formula F equals to ma, SI unit of force is written as kg meter per second square or simply Newton. So where 1 Newton is equals to 1 kg meter per second square. The CGS unit of force is written as 1 gram centimeter per second square or simply dyne, where 1 dyne is equals to 1 gram centimeter per second square. The relation between the Newton and dyne is nothing but 1 Newton is equals to 10 power 5 dynes. And the gravitational unit of force is nothing but kg, SI unit, it is written as kg weight or kg force, where 1 kg weight is equals to 9.8 kg meter per second square or simply 9.8 Newton, and 1 gram weight is equals to 980 gram centimeter per second square or simply 980 dyne. So based on this concept, let us try to solve few more numericals. Okay, and children, I hope you remembered all the 3 laws, kinematic equations, all the 3 laws. The first law was equation of kinematics was V equals to U plus AT. Second kinematic equation means S is equals to UT plus half AT squared, and third kinematic equation is V square minus U square equals to 2AS. So based on that, let us try to solve the today's numericals.